Assalamualaikum and hi, I'm Muhammad Ilham bin Basuki from FYS120 and Group 8. As we all know, chemistry covers basically everything in our life. Everything we see, smell, hear, taste and touch involves chemistry. So with such an enormous range of topics, it is essential for us to gain knowledge about chemistry at some level to understand the world around us. In order to gain knowledge about chemistry, a perfect topic to discuss is its chemical process and how it works. So, for the online chemistry presentation, I'm going to be presenting one of the most, if not the most famous chemical process in the entire history of chemistry, which is what? Haber process. Haber process, also known as Haber-Bosch process, is basically a method of synthesizing ammonia from hydrogen and nitrogen, which developed by the German physical chemist Fritz Haber. For your information too, he even received a Nobel Prize in 1918 for this specific method, which certainly made the manufacture of ammonia economically feasible. Then, the process was translated into a large-scale process using a catalyst and a high-pressure method by Carl Bosch, an industrial chemist who also won Nobel Prize in 1931 jointly with Friedrich Bergius for high-pressure studies. So that is why it is called Haber-Bosch process. In order to make the process work, what does it need? We certainly need a huge amount of hydrogen and nitrogen, but the question is, where can we get that? Just remember that 78% of the air is the nitrogen, so just take it from there. Whereas hydrogen requires a harder step. As for hydrogen, we can obtain it from hydrocarbons, for example like methane and steam, producing carbon monoxide as a byproduct. So when we have all these things together, we can make it work. But the question now is, how does it work? So the answer is the acquired hydrogen and nitrogen will be compressed and delivered to the reactor, which they will mix together to form ammonia with the help of ion catalysts. Then the formed ammonia will be transferred into a condenser and it will condense gaseous ammonia until it turns into liquid ammonia, which obviously can happen because ammonia has a fairly low boiling point. And I forgot to tell you this, but this reaction is carried out at a temperature of 450 degrees Celsius and at a pressure of 200 atmosphere. Because this reaction is a reversible one, there will be unused hydrogen and nitrogen. So the unused hydrogen and nitrogen will stay gaseous throughout the whole process, mainly because they have lower boiling point and will be recycled back to the reactor. So to make this process easier to understand, I'm gonna explain it step by step. Let's start with the first step. 1. Nitrogen extracted from the air and hydrogen obtained from the natural gas are pumped through pipes. 2. The pressure of the mixture of gases is increased to 200 atmospheres. 3. The pressurized gases are heated to 450 degrees Celsius and pass through a reaction chamber containing an ion catalyst to speed up the reaction. 4. The reaction mixture is cooled so that ammonia liquefies and can be removed. And then the final step, unreacted nitrogen and hydrogen are recycled back to the reactor. It's simple, right? So I did mention that this reaction happens under the condition of 200 atmosphere and 450 degrees Celsius. Why is that? So I will start with the temperature. As we know, this reaction is an exothermic one because it releases heat. Exothermic reaction requires low temperature to have a stable forward reaction and a higher percentage yield. But to achieve a higher rate of reaction, this reaction requires a high temperature, mainly because particles need a lot of kinetic energy for them to react. To solve this uncertainty of choosing the right temperature, 450 degrees Celsius is chosen as a compromise. Even though that temperature will give us a lower yield, it certainly causes a higher rate of reaction, which is our priority. Also, high temperature will cost a lot, so 450 degrees Celsius is just right. So let's move on to the pressure, which is 200 atmosphere. In order to achieve a high percentage yield, high pressure will be a perfect choice because there are fewer molecules of products than there are reactants. So the pressure will push the equilibrium to the right. Also, high pressure will produce high rate of reaction. Why is that? Because high pressure will force or push particles to collide with each other more frequently. So now that we know high pressure is better, how high do we make the pressure? So we need to consider these two factors, which are safety and cost. Maintaining high pressure will certainly cost a lot, and if the pressure is too high, it will be very dangerous and unsafe. So after considering both of these factors, 200 atmosphere turns out to be the right number of pressure applied. So that's basically all I have about the Haber process. I'm actually very fascinated and in wonder on how this process works or how the chemistry works in general. To conclude, I hope this video helps you to understand more about the Haber process and hope you enjoy it. This has been Ilham. See you.